Okay, guys, section 4.3, we're just going to look at graphing uh, sine curves and cosine curves and cosecant curves and all that fun stuff. Okay, so this is the assignment with the answers here. I'll go through the example with sine, and then hopefully the same, you can figure out the same thing applies for everything else. So a sine curve, if you remember what a sine curve looks like, it used to go to, in our old days, we used to go to 360 and call that the period, but now we use 2 over pi. So a sine curve, I remember this way. Which one's which? That looks like a C if you turn your head. So that's a cosine curve. That looks kind of like an S. So that's your sine curve. So a sine curve goes up and comes down and goes back like this. And it takes 360 degrees or now 2 pi to get all the way over. That halfway of that is pi over 2. Okay, half of pi is here. So halfway between here and here is pi over 2. This is 2 pi. That's 1 pi. In between is 1.5 pi, which is what we call 3/2 pi or 3 pi over 2. So that's your sine curve. Okay, and it has an amplitude of 1 and -1. And so if I look back here, what else is missing here? Let me just go back here. The y-intercept I'll get to in a second. The zeros are at 0, pi, and 2 pi. Let's go over it and see if that's true. 0, pi, and 2 pi. Yep. And then I said the period is 2 pi, and that's how long it takes to go one entire rotation of the curve. Amplitude is 1, and that's true. So the amplitude, it goes up pi over 2, or pi 90 is 1. And that's as big as it gets. So amplitude is the distance from rest position to the top, or half the distance from max to min, either way. So that is 1 from here to here. And that's the amplitude. Domain is unlimited, and the range is limited by the maximum and the minimum value. So the range is between -1 down here and 1. So -1 down here and 1. And it goes and goes and goes. Okay, so that is your sine curve. I'll redraw that a little nicer here. No, I don't need to redraw it. Let's go look at the inverse of the sine curve. Inverse of the sine curve is, so sine goes with, if you remember, cosecant. So what's going to happen here is you're going to get the inverse of the points. So the inverse of the points are 1 over the points. So cosecant is 1 over sine. So each of these y values can then be, each of these points here can then be put underneath a 1 here, or found as an inverse, and graphed. So for example, if this is 1, well, 1 over 1 is 1. Okay, so whatever's the black one is the sine curve. If I'm going to draw the cosecant curve, that guy is going to be 1 over whatever the black point is at. So here I'm at 0. So if I go, what's 1 over 0? So here I'm at 0. So 1 over 0 is undefined. So here I'm no good. I have nothing here. Over here I'm very low. So if I am at a very low number here, something like 0, half or something like that, 1 over a tiny number is a very big number. So I start here where I don't know where I am, and I come down like this, and it comes down and it gets lower and lower and lower, and it approaches 1. Now here, it shouldn't cross here, but here, this black curve gets lower, and as a number gets smaller, 1 over a smaller number gets bigger. Okay, so then I come back and I go back up and back up and back up and back up until I run into here where I end up at 1 over 0, which is again undefined. So not available or undefined. So now I don't have this point here. So this guy looks a lot like this. And what happens here is this takes off and approaches infinity. But it doesn't reach there because no one can reach there. But anyway, it gets higher and higher, and then it stops. And then when I come over here, now I have a tiny negative number, and 1 over a tiny negative number is a huge negative number. And again, as I get bigger here in the negative sense, towards 1, I get to -1, sorry. This approaches -1, and then they meet at -1, and then it takes off again. And then there I have another asymptote, because here I'm back at 0, and 1 over 0 once again is undefined, and that's what that looks like. Okay, so that's how your cosecant curve looks like. Your cos curve versus your secant curve will be very similar. Okay, there's your cos curve. And my cosecant curve, if that's 1, this is 1. It'll be the exact same thing. The only difference is it's kind of shifted. So this goes like this, And then when this gets to 0, I have another asymptote. Okay. And then this gets very negative, and this goes up like this. Asymptote goes like this, horizontal asymptote. And this is very small, negative. So the inverse of that is very big, negative. And I approach 1, and I get to 1, I come back up, and again, like this. And if you notice, this really has become this one here, the secant curve here in green is a shifted cosecant curve. And just like a sine curve is a shifted cosine curve. Okay, so hopefully that makes sense. When you play around with the tan curves, they look a little weird, but it follows the same rules. Okay, so a tan curve looks like this. Okay, so there's my very fancy tan curve, and save a little time by pausing the video. So what happens with the tan curve is I start here and I start at 0 here, and I approach as I approach pi over 2, it gets bigger and bigger and bigger, and then at some point there's an asymptote here at pi over 2, and then I start down here at pi over 2, just to the right of pi over 2, and this comes up and crosses right at pi, and then goes back and takes off again at 3 pi over 2. If you're confused by this, always just go over to Desmos, type in what you're looking for, and change your make sure that you've changed to pi when you're looking at your domain and range. And then if I want to do my cotan curve here, it's 1 over these. So each of these, so 1 over close to 0 is undefined. Okay, so this guy's here, and then this guy is tiny. 1 over that is huge, and they look like this. Okay, and it comes down and it looks like this. Okay, and it goes like that, and then this guy comes down like this, and it has an asymptote. That's a horrible drawing, but it has an asymptote here. Okay, so every time this guy crosses 0, you can look at it's kind of neat. Whenever the red one crosses 0, the blue one has an asymptote. Whenever the blue one crosses 0, the red one has an asymptote, because 1 over 0 is undefined. So that's how you get your horizontal asymptotes. This guy here, we read our graphs this way, left to right. So this one declines as the red one rises. As the red one continues to rise, this blue one continues to decline. Okay, it gets smaller and smaller and smaller. So this one here is at 0. So here that's at 0, so I have an asymptote. This one is small, and getting bigger. So this one is a replication of this one. It starts doing this again. Sorry, it starts doing this again, and it keeps going and going and going. Okay, and what you end up seeing is it looks very pretty. They crisscross each other all the way across, and that's all based on the fact that when you take the inverse of a function, you take the inverse of the points. So when you're looking at this, you can think of it that way. Okay, just think of each point. If I had a y value, whatever that is, well, my new y value for my inverse is 1 over the old y value. So hopefully that makes sense. Where do you get the information? Where do you get the zeros? Where do you get the period and all that stuff? You got to get them from the graph. Where are the zeros? The zeros for the blue one are here, here, and then where's that? Pi over 2, 3 pi over 2, etc. Okay, hopefully that makes sense. If you have any more questions, just send me an email. Take care.